Hello, my name is Andrew Chen. Today I'll be going over the TRI, or the Toxic Release Inventory Program. This is research data collected by the Environmental Protection Agency, which shows the various companies nationwide that are responsible for releasing various chemicals in the environment, the type of chemicals that are released, and the amount released. I'll be using Excel to show the areas that are being affected and which companies are major contributors to waste, among other things. The data I collected was from EPA.gov. I had the options to choose from various years, national files, federal files, or data files by state. I focused on the most recent year, 2016, because data has not been entirely collected for the year 2017, and I concentrated on New York State, as you can see in the original file name, TRI 2016 New York. As you can see, there is a lot of data that we're working with 111 columns and 1,961 rows. I have taken the pertinent information and pasted them into a sheet called Relevant Data. Now we still have a lot of information here. For this study, I reduced the columns to 12 and took the first 100 entries to make readable clear graphs and maps. This data is geospatial, so we don't have too many numbers to work with. I took the city as well as the coordinates for each waste location. Coordinates are much more reliable to use than street address, county, and state combined in creating maps, which I will demonstrate later in the video. I used the chemical name, of which several exist. I wanted to know whether that chemical was regulated by the government's Clean Air Act. For classification, we can find out whether that specific chemical is a TRI or a PBT. We discussed earlier that a TRI is a chemical that falls under the Toxic Release Program, and so is monitored and studied by the EPA. PBTs are persistent bioaccumulative toxins. These are chemicals that require extensive treatment to properly handle. They can be found and spread to living organisms, and as the name suggests, they are toxic. It is important to know also whether these chemicals are carcinogenic, the amount the companies are dumping in pounds, the names of the company, and pertinent information for location. Now let's move to the pivot table. If we look at the pivot table, we can see the names of all the chemicals present. Under slicers, we can see where these chemicals would be found and the various characteristics. For example, if I wanted to know about chemicals released by companies in the Bronx, I would click on Bronx, and we see trimethylbenzene under chemicals, which are not covered by the Clean Air Act, they're non-carcinogenic, and they're TRIs. But let's say we only wanted to focus on carcinogenics. I would clear the filter, hit yes for carcinogens, and we have our list of chemicals as well as where they're located. If I wanted to further filter this list and look at only persistent bioaccumulative toxins, I can do that too. And if I wanted to see what exactly is happening in Niagara Falls, for example, we can certainly work that out. And we can see that lead is the leading chemical in Niagara Falls. Now let's move to the company waste sheet. As you can see at a glance, these company names are nowhere near the maximum value on the y-axis, and the pie chart is quite clustered, but we'll be focusing on the column chart for now. Now we have a long list of companies that we're dealing with here. Keep in mind that I cut down that list from 1,961 values to the top 100. Now if we look at who's the top waste producer, it's easy to see. Solvents and Petroleum Service Incorporated. That's a good thing they're non-carcinogenic. But if we wanted to focus on those carcinogenic chemicals and the companies dumping them, we can certainly do that. We can filter the data and see that Xerox is the major contributor. We can do the same for non-carcinogenics. And we get a slightly shorter list than the original. Now we'll be moving on to the map. As you can see in the fields list, I've used city under locations, the coordinates in their respective spots, and carcinogen for color. You'll also notice on this map that we have some points that are both yes and no. So let's take a closer look at one of them. We have horse heads. If we go back to our pivot table, and we look specifically at horseheads, by clearing out all these filters, we'll see two chemicals listed, chromium and copper. Well, which one is carcinogenic? We can certainly find that out. Chromium. So copper is non-carcinogenic. But not only that, I can go back to the company waste sheet. I can filter this city under this pie chart. And again, we see these two chemicals, chromium and copper. And now we also know the company name, Eaton Corporation. I'll be moving on to other maps now. We'll start with the top graph. I broke down the locations by classification for all of the values in the original data set, not just the top 100. And as you can see, New York is pretty much covered. But what we can do is focus on Manhattan. Here we are. And we'll notice that both PBTs and TRIs are present. You'll also notice that there's a classification called dioxins. I can go back to the first map and replace carcinogens with classification, but I'll only end up with PBTs and TRIs. Why is that? Like I said earlier, this map is a culmination of all the data sets, not just the top 100. So what is a dioxin? They're like PBTs in that they are persistent. These chemicals are commonly transmitted through food and settle in fatty tissues where they can reside and cause various health problems. Let's see if we can find a few dioxins. I see some located in Northport, as well as Middletown, just to name a few. Now I included this final map as something I learned along the process of this project. In mapping these locations, I thought it would be helpful to know the street address in addition to zip code, county, and city for more accurate information. That is not the case. If I gave street address, I would be across the Atlantic into Europe and in Australia. Same goes for city. With county, at least I'm in the US. But the most reliable that I found was zip code. For all the datasets are located in New York. We'll also notice that there are some larger circles. Let's take a look at one. If we click it, it highlights on the top map as well. And we'll see that it's located in Buffalo. We can now go back to the company waste sheet to filter out Buffalo. Here we are, and we have chromium and nickel as the two main chemicals, and we also know the company name, Ingersoll Rand Corporation. Now that we know the chemicals involved, we can find a parent company, and we can use that in this top graph. By clearing the filters, I can take the parent company name that I now know and see that they are mainly dumping carcinogens. And I can compare this to all the companies dumping carcinogens. And Ingersoll is right here. I can now go back to the pivot table. Clear the filters. I know that it's located in Buffalo. And again, in the pie chart we have the two chemicals, and we see them here as well. And we also know that it is a Clean Air Act chemical, that it's carcinogenic, and that it is also a TRI. It's clear to see that Excel can be used in a variety of situations to clearly organize and visualize datasets, even with something as complicated as waste production in New York State. I hope the information that I provided was understandable and clear. Thank you.